thought there's something more exciting. Okay. There we go. I'm unmuted now. We're all good. The highlighter button's about to work. This is on page 83. What we're going to look at today is square rooting any function or square rooting any graph. And what happens. And we've already seen that there are 2 points where the square roots are the same. And there's points where sometimes you square root something and it gets bigger. And sometimes you square root something and it gets small. Now, you already know the basic square root graph. This was in our transformations unit. It had 0, 0, 1, 1, 4, 2. No problem. But what we're going to learn in this unit is a new technique for graphing any square root graph. Because up till now, we've only been able to do basic square root graphs and their transformations. The new technique says graph what's inside. So if I wanted to graph the square root of x plus 4, right now you could do that with transformations. Can you see that that's a square root graph? Move 4 to the left. And that would match up perfectly with the blue. But the new technique says if you can draw what's inside, y equals x plus 4, that's a straight line, y-intercept of 4, slope of 1. If you can graph what's inside, and then look at the picture of the graph inside, the square roots that don't change are 0 and 1. So here is the point where the inside is 0, right? X plus 4, when x is negative 4, y would be 0. And here is the point where the y value would be 1. When x is negative 3 plus 4, that would be 1. Those 2 points are going to be on both of them. Because if you square root 0, you get 0. If you square root 1, you get 1. Next, there are some numbers that are easy to square root. The square root of 4 is 2. So if we see any square roots on the inside graph, all right, if I call the red graphs the inside graph, if we see any things that we can square root easily, we can put those points on there. Everywhere where the y values are bigger than 1, when you square root most numbers, they get smaller. So our blue graph will be smaller than our red graph for most of the numbers that we're used to. Anything bigger than 1. You square root it, it gets small. But between 0 and 1, when you square root something, it gets bigger. Only slightly bigger. It never goes like way high, never goes past 1. Just a tiny bit bigger than the original graph. And so, although we already knew how to draw the square root of x plus 4, now we have a new technique. And the nice thing about the new technique is we can draw the square root of anything inside that we already know how to draw. So this unit allows us to review the entire transformations unit and the trig unit. We can square root sine graphs if we wanted. We might. No. We could square root x cubed graphs. We can square root anything. Here is a great example of one where I think the new technique is better than the old technique. Because in the old technique, this is what majority of students who make a mistake do. They see the negative and they do a horizontal reflection. Perfect. Then they see the plus 2 and they say 2 to the left. But this remember the special note in transformations that when you have a horizontal reflection, and a horizontal translation that you would have to write it first in factored form, so it's actually 2 to the right, and then everybody forgets the factored form and makes the mistake and goes 2 to the left. However, if you graph the inside first, negative x plus 2, that's a straight line with a negative slope, a y-intercept of 2, a slope of negative 1, you would get this red line. From that red line, it is relatively easy to find out that when x is 2, y is 0, the square root of 0 stays the same. When x is 1, y is 1, the square root of 1 stays the same. Whenever you square root, oh, here's a nice point. That's when the y is 4, so on the blue graph, it's 2. Whenever you square root a number bigger than 1, so this is where the red graph is bigger than 1, your blue graph would be smaller. And in between 0 and 1 for your y value, this one would be slightly above. And you wouldn't make the mistake of going 2 to the left instead of 2 to the right if you did that. So I think this is a good example of, we could have done this before, but the new technique is better. I would say for the first one, we could have done it before, and the old technique is still better. It's really easy to take the square root graph and move it 4 to the left. But this one, you might have forgot the factored form and made a mistake. So overall, what do we always do when we can graph the inside and graph the square root? We're going to highlight some stuff in here. Just click all these first. Okay. Right behind the side here. When y is equal to 0 and y equals 1, the square root of 0 equals 0. Maybe you even want to write the square root of 1 equals 1. Those are the points that are on both graphs. And those points that are on both graphs that don't change, we call them invariant points. Beside this one, just me summarizing it very quickly. When the y values are between 0 and 1, your square root graph is above your original graph. But when the y values are bigger than 1, it's below. Okay? And the last thing that we didn't really talk about because it was kind of obvious, but maybe not so obvious. Would you agree that you can't square root a negative? So if you had a negative number, it's impossible to square root it. It won't show up on the new graph. And we're going to see some examples. In fact, we saw that in the last examples. Okay? I'll just wait. Is everybody done here? If we go back to our last examples, right, the square root, the line keeps going, but we never drew anything for the square root because you can't square root the negative number. Here, the red line kept going past 2 when x was 3, when x was 4, but because they're negative numbers, the square root doesn't exist. So we just have 0 and 1 slightly above and below as our way of graphing. And this is our entire first section of this new unit. So now, Sometimes they give you an equation, and you have to graph the equation yourself first, and then graph the square root. And sometimes you'll just be given a graph and asked to graph the square root of it. So this is example 1. We're given graphs, and we're asked to graph the square root of those, and then give the domain and range of the new graph. So if I want to graph the square root of this line, the very first thing you're going to find are those points that don't change. Square root of 0 is 0. Square root of 1 is 1. So you just go on your y values. Here's the y value of 0. There's the point. Go up to a y value of 1. There's the point. Those are the two most important points to graph on any square root graph. Then after that, see if there's any other nice ones you could do. Is there any other nice square roots? Yeah, we got 4. Square root of 4 is 2. Ooh, technically, isn't this 9? I could go straight down and do 3. Because the square root, this one's 8, but right beside it, isn't this one right here? Isn't that 9? So I went straight down and said square root of 9 is 3. Now our final graph, between 0 and 1, slightly above. After 1, it needs to be below. Now you can lose marks on the slightly above. I'm going to now show you how to lose marks. I know you're saying I'm already very good at that, Mr. Chair. I don't need any. No, but sometimes, okay, I'm going to, oh, that was a huge raise. People normally don't lose marks on the below, but on the slightly above, they lose marks. Here's one way of losing marks on the slightly above. That is not slightly above. That is weight. If you go over the 1, you went too high. Okay? So that's one way to lose marks on the slightly above. Another way to lose marks in the slightly above. That's slightly above. But you also went back in time. You did that. Okay? This, ooh, a little bit back in time can lose you a mark. Sometimes the best for the slightly above is to be like you're almost drawing it right on top of the line. Is not bad. Just like try to draw it on the line and maybe a tiny bit above is going to be fine. Because some of them are going to be really hard to do the slightly above. Let's look at the second one. It's not too bad. Do we have any places where y is 0? Yes. Do we have any places where y is 1? Yes. Do we have any nice points on this one? Not really. Because it doesn't get to 4, does it? I mean, technically, if you kept going, it looks like it would hit 4 there. So I could say it's going to hit 2 there. I could estimate it. It wouldn't be bad. Maybe you know your square roots of other numbers. Does anybody know what square root of 2 is as a decimal? 1.414. What about square root of 3? Anybody know that one? No? 1.73. Oh, so close. Right. Things you don't need to know. Don't need to know square roots of numbers. Square root of 5? 5? Yeah? 2.2. No, 2.236. Oh, you're close. So, we've got our 0 and 1. We've got between 0 and 1, slightly above. That's all it needs to be for slightly above. And then after that, below. It would stop here because here it's negative, right? You can't square root a negative, so it would just stop. Now, you can circle question number 5. We'll do example 2.